So should I just give it another minute or so, or is the usual rubric just to start on time?
I think Aleko is joining in, he's sharing.
I thought so, but just in case he's got problems. Okay.
Yeah, he's connecting his audio.
Ah. I can still see it's trying to connect.
Apparently, this network. Just give me a few more minutes.
I think Alekos may have a problem.
Yes, I guess so. I think we can just start.
Shall we make a start? So,
yes.
Well, I'll just introduce myself if that's okay, Aki.
Please, please go ahead.
Yeah. So, so first off, thank you very much for this opportunity. So I've been a member of SEGH literally since I was doing my PhD, frightfully a long time ago. So I'm not going to tell you how many years ago. So I'm Professor Jane Entwistle. I'm currently at Northumbria University. I'm one of the fellows of the society, and so therefore we have this opportunity every couple of cycles in order to do a kind of half-hour update presentation with an opportunity for some discussion after. So hopefully I've pitched this at about the right level in terms of stuff to think about and a little bit about a new project, not too much data, but let's see how it goes. So thank you. So I'm an environmental scientist, a geochemist. I know much of the many of the members of the SEGH community, but over the years, I guess I've had an increasing focus on exposure science, but also exploring ways we can work with and for communities to improve our environmental health literacy. A lot of my projects over, I think, probably about the last decade, are working in real-world environments to try and improve our practice, policy and decision making. And I think this is a good example of that. And I want to talk about, I guess, the net zero challenge. So the net zero challenge offers the SEGH community research opportunities. And I want to kind of give a couple of those examples today. I'm going to highlight with a focus on particulate matter. Why PM? We've heard about it for a long time now, but particulate matter is now very well recognised as a valid surrogate health metric. So that means we're able to apply directly now for health funding as well as more environmental science funding. And also, I want to highlight some approaches where we can quantify health and well-being directly. So I've noticed over the last decade plus that as a community, we often use our environmental data, and we do quite a lot of calculations and use algorithms, but we don't often use questionnaire surveys that are targeted at capturing and understanding health and well-being of the communities we're working with. So I've dabbled into that as well with colleagues from Newcastle University. So I guess I want to kind of put that across as well, and in the hopes that more people going forward may decide that this is also useful to help capture well-being in communities. So that's what I want to do. So very much, it focuses very much on net zero. So I think tackling climate change and air pollution offers, one of the greatest global health opportunities of the 21st century. The UK, like many countries around the world, is setting challenging targets to reduce the amount of greenhouse gas we emit, the so-called net zero 2050 challenge, specifically around the UK with some stringent targets. Our housing sector, which is the focus of the bulk of my talk, is responsible for about 16% of these greenhouse gas emissions. So housing providers and homeowners are implementing changes to homes to reduce the amount of energy we use, and particularly the amount of energy from fossil fuels, the way we heat our homes, the way we run our domestic appliances, etc. So we need to make sure that with these energy efficiency improvements, we also improve where relevant, but certainly don't make any worse, our indoor air quality. So energy efficient installations that I'm kind of talking about are things like double glazing, better windows, better fitting doors, cavity wall fill, insulation in roofs and floors. So they have a potential to reduce our energy bills and our carbon footprints, but also they have an ability to increasingly seal up our homes, making them more airtight and reducing natural ventilation. So research around the impact of energy efficiency interventions has a real role to play in looking at the evidence base for how we maintain or even improve indoor air quality. And this is the focus of the project we've just done the first 6 months of. It's called Into Air. It's a collaboration between Newcastle City Council, who are doing the energy efficient retrofit renovations to homes across the city, social housing across the city, and Newcastle University. So I'm working with colleagues at Newcastle who are in the health end of this. So some of the questionnaire surveys and materials I'll mention are valuable if we're going to look at how to quantify these health, the benefits of the interventions in terms of health value, health gain, and therefore a broader economic piece. So let me tell you a little bit about Into Air. So we've just done phase 1, which is the first 6 months. We've focused initially on 30 homes. So we've done what's referred to as a baseline survey. So in order to do this kind of look at the impact of retrofit, we need to know what the homes are like before the retrofit, then the retrofit takes place, and then we look at them after the retrofit. So it's very much a before and after study. So the first batch of homes, the first building typology we've looked at to get our teeth into with the protocols, were 30 small bungalows. They were inhabited by elderly residents, largely 65 plus, but we did have a few 55 to 65-year-olds in the sample cohort. They're owned by the City Council, and they're all now undergoing a range of energy retrofit building works. This is what they look like. These are the very small bungalows. Because it was the first batch we were doing, we wanted to hold quite a lot of the confounding variables across a home set static. So small homes, elderly residents, so there were no children. This is what they look like. They're all arranged around these greens. So a little bit of a kind of overview of what they look like. So there are at least 4 types of bungalows: small end terrace, small mid terrace, and then we've got a couple of slightly larger ones which have 2 bedrooms. So they're fairly similar in terms of that typology. Most of them have 1 inhabitant, some have 2, and we monitored their current air tightness by doing what was referred to as in the industry as the blower test. So basically, we close the windows and doors, we reduce the air pressure in the house, and we see how long it takes for the air pressure to get back up to ambient levels. So we see how leaky the property is. So which protocols have we implemented? Again, we've been working with the council and the architects to do things that are also sustainable to be done at scale. So we've used low-cost sensors. So we've focused on low-cost sensors called IQAir sensors. So I'll say a little bit more about them in a moment. But we did paired outdoor and indoor sensors. So here's the outdoor sensor here. You can see my little mouse moving around, hopefully you can. And it's connected by a cable, a very flat cable that goes through the window into the indoor sensor, nicely modelled by one of the participants' cats here. And because it's involving putting bits of outdoor architecture furniture onto the council property, we had to have a whole cohort of helpers to screw on the very small bracket. So it is easy to do. It just involves quite a lot of people when you're doing things with our councils in the UK, for those of you who worked with the councils. So we measured outdoor PM 2.5, 10, temperature and humidity, and we measured indoor, the same metrics, but also CO2. So we measured the CO2 indoors, again, as another surrogate for indoor ventilation. So the council, members of the council and the architects in particular were really interested in temperature and humidity and CO2 changes. I guess we were more interested because it's a surrogate health metric, the PM 2.5 and 10 concentrations. A quick overview of the IQAir monitors that we used. This is an indoor one, this is the outdoor one. They're about £300 each. They measure a whole range of PM, light scattering devices, and CO2 is by non-dispersive IR. So we purchased a whole batch of these, and they come fresh out the factory with factory calibrations. But I guess here is one of the kind of big things we must do, as with any monitoring programs, we have to do a whole batch of quality assurance. It's absolutely essential. So we needed, although they came out factory calibrated, we needed to do a whole batch of co-location. Does each sensor and monitor tell us the same thing when it's in the same room? And we also wanted to do some of our own calibration checks. So just a little bit of information now about how the IQAir worked. So the first thing we did when we tried to make some decisions about which low-cost sensors we were going to use is we scoured the literature, and we found quite an increasing body of evidence that these IQAir sensors were comparable to federal equivalent method, which is the kind of gold standard method used in the States. And this is data from the States that was being reported to show, I guess, the accuracy of the IQAir units. So the red line is the federal equivalent, I guess, high-tech PM monitoring equipment, and the other lines are some individual IQAir devices. So this prompted us to purchase these devices in the first place, but we also did our own co-location study. So we put all of the indoor and outdoor devices together, and we ran them for 8 days. So you just have to make sure you've got lots of plugs if you do it in your own living room, which I did. And what did we find? So what we have here is a quick screen grab of all of the different particle monitors and how they correlate with each other. What I should just flag is one monitor that wasn't working. So we'd had a problem with this monitor. There was something about, anyway, I won't go, it's an anecdote, I won't go into that. So we knew PM monitor 8 wasn't working, so we removed that from the study. If you have a quick look at the scatter of plots, we're fairly happy with how the PM monitors were all monitoring the same thing in my living room. Monitor number 3 did provide the most variability. So going forward, we're also not going to use the monitor 3. So they all came out the factory, they were all calibrated, they were all brand new, but we did find some variability. So it's a cautionary note, do a co-location study before you deploy all of your sensors. So high inter-unit precision in the main, once we remove these 2 offending ones. Correlations for indoor and outdoor monitors. Again, we found quite a good consistency when they were sat together, co-located. The indoor and outdoor monitor were telling us the same thing, apart from number 8, which we knew we had a problem with for some specific reason. And monitor number 3 was more variable. It was acceptable, but we won't be using it going forwards. PM10 we find far more variable. So whilst the monitors will do PM10, they're far better at PM2.5. And from the point of view of a health metric, then we are increasingly concerned about PM2.5, and we're moving away really from the preoccupation with PM10. So we were less concerned that these low-cost sensors weren't monitoring PM10 as reliably as it was monitoring PM2.5. A quick look at CO2, for monitoring for the co-location of the CO2. The data was incredible, really good reliability across the sensors for monitoring CO2. What we haven't yet done is co-locate the CO2 sensors with a kind of gold standard model. So we're waiting for a bit of work to be done by the UK Building Research Establishment. They're having their CO2 sensor calibrated at the moment, and they will take some of our sensors and we'll do a precision, an accuracy check, just for confidence that we are correctly recording CO2 concentrations. So that was, I guess, a tale about the importance of co-location. So you get a sense of the inter-unit reproducibility, but also getting some sense of the accuracy of that data. So to jump to something quite different then, so surveys, but surveys focusing on how we capture residents' activities, but also in a moment their health and well-being. So we worked with the Building Research Establishment, BRE, and we used and adapted with them one of their surveys, which looks at ventilation, air quality, captures participants' reflections on thermal comfort, heating and energy use. And I should say, if you want to access any of these surveys, they are now freely, we've uploaded the protocols online. Please feel free to go and grab them and adapt them. So we used this first survey. Then, I guess possibly the more interesting end of the surveys we undertook for this community is the health and well-being survey. So the quality of life survey, something that is established and it's widely used health-related quality of life measure. It considers 5 domains. It considers mobility, self-care, activities that people do in their everyday life, at what extent they feel pain and discomfort through engaging with those activities, and their level of anxiety and depression. So it's called SF36. You have to get a license to use it. So you submit a questionnaire, an application to the organisation called Quality Metric. For many academic applications, such as the study we were using, they license you to have it freely available, and they also send you a scoring algorithm. So this is what we did. I'll show you some of the results of this particular survey shortly. The other survey, which is freely available, again, you have to register to use it. It's a quality of life or capability survey. There are different versions. There are versions to young with younger people, older people, or adults, so the 18 plus population, which is the one we decided to use. And here it looks at capability, and it defines well-being in terms of an individual's ability to do and to be the things that are considered important in terms of somebody's well-being. So they're things like feeling settled and secure, love, friendship and support, independence, achievement and progress. You see these categories, enjoyment and pleasure. And the participants respond, and then they get scaled on a 4-point scale, from no capability to full capability. And so, like the other questionnaires that I've just mentioned, the SF36, it's converted into a numeric term. And then these numeric ways of capturing health and well-being can be fed into both our models, our statistical models, but also start to inform how we quantify the health economic impact of some of these interventions. One that was specifically requested by the health economists was something called use of services questionnaire. So again, this is a questionnaire that the participants complete. They reflect on their use of health and social care services 3 months prior to the interview. And it captures the way they interact with health and social services, and then we cost it per individual. And there are ways to cost it. So in the UK, we use the NHS costings, and you can look up unit costs of health and social care. So whether or not there was an appointment with a doctor on the line, whether it was a video call, whether it was a face-to-face call, whether they saw a general practitioner or they went to a hospital to see a consultant, and you can cost all of these. So you can see how readily this can then be used as part of economic evaluations. We also did an energy survey, so I won't dwell on this, looking at participants' bills, and we've also got some equipment looking at energy use over the long term installed in a couple of the properties. I think I also want to highlight, I guess, to the SEGH community is, as I'm sure many of you know, the importance of having a community engagement plan. So, you know, really plan it, and as part of your funding application, fund it. It's one of those things that often gets squeezed because we want to collect so much data and we want various elements of kit. But I think we really do need to be suitably funding and accounting both for time and what we need to deliver our community engagement. So what we did specifically is we recruited members of the community to work with us to help in the recruitment of our participants. As you can imagine, we generated a range of advertising materials, which we trialed with some groups before we actually went out to everybody. One thing we built into the project was the importance of being able to, we purchased a load of vouchers, but what we did was we costed them into the project, but then we worked with the participants to see which vouchers that they wanted. And so we could then clearly give them some form of thank you for taking part. We returned all the individual participant feedback. It was hand delivered, so occupants have an opportunity to ask us, the researchers, questions as we delivered the feedback. And also we had a number of community events, buffet lunches, coffee afternoons, in order to, I guess, really better engage with the participants and talk to them about our findings. So a couple of very quick summary slides, and then we have an opportunity really for any queries or questions. So I'm not going to dwell on the data. So the initial 6 months first baseline work on the first typology of homes concluded in March, and we're just pulling the data together now, but this isn't a talk on a particular research project, so I'll just do some of the highlights. So from the 30 homes in this baseline, this was the findings in terms of the mean particular PM 2.5 concentrations that we found. So this is each individual home's mean during the period of time monitored. So we monitored the homes from somewhere between 3 weeks and 5 weeks. So this is the mean over that period of time. And the error bar is a standard deviation of that mean. So from the council's perspective, it was largely a good news story that if we do compare the current UK annual average PM2.5 guideline to our monitored period mean guideline, then all of the homes were below the 25 microgram per metre cubed, but not the smoking homes. I have taken the homes out where a couple of the participants smoked. They did say they wouldn't smoke when we signed them up, but you know, people do. It was cold. A lot of the monitoring went on around December and November in the UK. So I've removed those from these average means. But what it also shows us is that if we look at the current WHO mean for PM2.5 annual mean, then there are 21 of our 30 homes that exceed that the new WHO value. We also looked at each day's, the 24-hour mean for each household. And we found that 20% of the days monitored across these 30 homes exceeded the WHO 24-hour guideline of 15 microgram per metre cubed. So we had some homes that had no days over this 24-hour exceedance guideline, and the smokers' home had 100% over. It clearly stressed the importance of us giving feedback about, you know, if you're going to smoke, smoke outdoors, and also we provided some general flyers and guidance on how to make contact with your local GP to look at ways to stop smoking. But I say it's not our role to preach to the participants. It was about providing some guidelines and information. I would also flag that the UK government has said it's planning to set a target for annual mean concentration limit of PM10 to lower to 10 micrograms per metre cubed by 2040. So what this meant is, you know, if we are funding, which we are at scale, these energy efficient retrofit plans across the UK, we probably do need to be future proofing them, not just making sure that the indoor air quality meets its current guidelines, but that we're going to be meeting current guidelines by the time we hit 2040. So at the moment, we're looking at what we're quite interested to see the post retrofit survey to make sure we're building in sufficient ventilation. So the architects are clearly looking at the data we have in terms of what more can they do in terms of this retrofit to build in more ventilation. A couple of other summary slides. So CO2 was particularly of interest, I say, for the council and the architect. It's used as a surrogate measure of indoor air ventilation. The majority of homes had a relatively good CO2 concentration throughout the monitoring period. Some fell into the moderate category. So now we're interested to see, after the intervention has taken place, and we're, you know, to what extent are we sealing up the home? How do the CO2 levels vary? And also humidity. So again, a key driver for many of the I guess preoccupations and social housing of the council are making sure that we don't have too high humidity in our homes, because they drive mold development. And in the main, the most of the homes at baseline, so before the intervention work, the energy efficiency work, show very much that they're falling around this what's considered healthy humidity level, which was good. However, there were 4 homes that have 50% of their monitoring period with humidity that fell outside this kind of generally acceptable norm, greater than 60% humidity. So that does indicate we have a number of homes of increased risk of mold that, again, as part of the retrofit works going forwards, the council might like to consider how better to retrofit some of these properties specifically. Almost my final slide on the into air. So I mentioned that I wanted to try some of these health and well-being validated tools. And the one I used, I mentioned earlier, SF36. So what that does, it provides you with some summary scores. So you can calculate through the algorithms quality metrics supply a physical component score, and you can look at your cohort in terms of general population. I should say the general population that we compare to is the US population, but it kind of gives a state of play, a baseline for our community. So the majority of occupants, remember we were working with largely older community, their physical health was below the norm, whereas their mental health score was largely above the norm. And this was a really positive finding for us. And we think it's very much because of the community layout of this social housing around these courtyards with community activities that are available. But again, I'm not going to dwell on a lot of the data for this talk, just kind of give you some highlights. And now obviously we're feeding into a number of multiple regression models, all this data. So we're being able to feed in the questionnaire data as well as the environmental data. So more on that at the Athens conference. So a couple of take-home messages and next steps. I should just flag, we found this neat way of providing, well, we think it's a neat way of providing some information back to each individual homeowner about their indoor air quality. So what we did for each home was we provided them their changing particulate load on a 24-hour clock. So they could see, home 7, that they largely increased their particulate matter in their home at their evening meal time. So they could think about how they might increase ventilation during that period of time. And at home 3 was almost the exact opposite. So they tended to mainly influence their particulate matter concentration in their home during their breakfast around 9 and 10 o'clock in the morning. So take home messages and next steps. So we're going to go back 12 months after the retrofit's finished to do all the resurvey. We're also hoping to get some additional funding to roll it out across a range of other building typologies. This needs to be done at scale. We've only done it on bungalows and 30 bungalows at this point in time. But why I kind of want to flag it, as I really do believe it's an opportunity space for the SEGH community being offered by this transition to net zero. There's a lot of money for retrofit going on. We are, as a community, comfortable working in multidisciplinary teams, so working with people who want to do health economics and health statisticians, built environment staff who are focusing on both architecture but also fuel monitoring. Particulate matter is now a well-accepted surrogate health indicator, so we don't always have to monitor some of the other health metrics like lung capacity or lung efficiency or changes in those metrics. We can actually monitor the changes in particulate matter as a health indicator. And also, obviously, we're very aware that particulate matter is not a single pollutant. It's a complex mixture of solids and aerosols. So, you know, particulate matter monitoring for us also opens up an opportunity to look at the changing nature of chemical composition. And the why I also flag that is that given I'm kind of reflecting and thinking about net zero and how we go about, you know, reducing greenhouse gas emissions to help improve climate, help tackle climate change, I've mentioned really about improving efficiency. But obviously there's a lot of work going on about low carbon solutions, electrification, hydrogen, carbon capture and storage. And it's really fascinating to look at how this is changing mining activity and mining of specific, I guess, net zero required minerals. So here I've just grabbed a couple of slides from the Critical Minerals and Energy Transitions report that just shows the kind of rapid deployment of clean energy technologies as part of this energy transition and the increase in demand for certain minerals, copper, nickel, manganese, cobalt, zinc, all the kinds of elements we talk a lot about as an SEGH community are becoming critical minerals going forward for our energy transition. So obviously we're moving away from coal and oil and increasing our need for these particular minerals, elements, I should say, although it says minerals from the report. So, you know, and we can see this transition in terms of the revenue production. The grey bar is coal, and the coloured bar are these new minerals, looking at the elements that these minerals contain. So copper, lithium, nickel, you can see are all growing in their need as part of this energy transition. So I guess I'm asking, you know, how is this going to change potential exposure patterns in the next decade? And, you know, we know it's changing the geopolitics of our world as well. You know, where are these critical elements located? Copper, huge reserves in Chile and Peru. Nickel, we're looking at Indonesia and the Philippines. Cobalt, large reserves, and particular the main producing countries are the Democratic Republic of Congo. So, you know, I think as an SEGH community, net zero offers not only funding opportunities, but also we need to be thinking about what are the next generation of critical minerals and how are we altering and changing our exposure profiles over this next 1 to 2 decades. So hopefully that's given a kind of a whirlwind tour of my current world, which is focusing on net zero. And obviously I couldn't do anything around IntoAir without many of our participants, Kat included. So this is really just to say thank you to some of the people that have been involved. And the project is very much a collaboration with a range of colleagues across this multidisciplinary team. So thank you very much for listening. And I hope you found that of some value or relevance or some thought-provoking about where your next research project may lie. So I'm going to stop sharing my screen. And hopefully, do you see me again or do you still see my slide?
We're seeing you.
Great, thank you. Thank you very much, everybody.
Thank you. Aleko, over to you.
Yes, I'm supposed to coordinate. Anyway, thank you very much, Jane, for an excellent talk. And now we're open to questions.
So I don't know if you want to stop the recording. So people, if we stop the recording and then we can have a bit more of an informal discussion without capturing everybody if they don't want to be captured. If Olivia can.
Olivier.
We can stop the recording.
Do you want me to stop recording? I'm happy to.
I think, and then people can talk freely if they wish without being captured.
Okay, Olivia, yeah.
Let me just figure out how to do that.